Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. My name is Fatin Fatihah binti Nazri, a final year student of Applied Chemistry at University Technology Mara Arab Perlis. Today, I will be presenting my final year project titled Phytochemical Constituents and Antibacterial Activity of CLITORIA TERNATEA L. Rose Extract, which is supervised by Dr. NURUL, ZAWANI binti ALIAS. To begin with the presentation, we will look at the table of contents. I will cover the introduction of problem statement, significance of study, objective, literature review, methodology, discussion, and last but not least is conclusion as well as recommendation. CLITORIA TERNATEA are known as butterfly pea, where the family of the plant is Papaceae and the subfamily is Papilionaceae. In Malaysia, it is well known as bunga telang. CLITORIA has been used to treat many types of ailments, as previous studies reported that the whole plants and seed extract can treat stomatitis, pus, psoriasis in female, insomnia, and etc. Other than that, the aqueous extract of the flower is used to color white rice for nasi kerabu and also desserts such as cakes. The roots of CLITORIA TERNATEA had been used as reputed nerve tonic, and it is believed can promote memory and intelligence. In addition, the root extract of CLITORIA TERNATEA was mixed with honey and ghee as a general tonic to children for improving mental faculties, muscular strength, and complexion tonic. Phytochemical screening of CLITORIA TERNATEA showed the presence of alkaloids, flavonoids, tannins, phenolics, and saponins, where some of these can possess to antibacterial activity. As we can see, there's a lot of antibacterial product in pharmaceutical, food, chemical, and other industries because people believe that this product can inhibit or kill bacteria. However, this product use synthetic chemicals to impart the antibacterial activity. A study stated that the chemicals have been proven to cause several skin allergies and also identified as carcinogenic. Hence, natural antibacterial compounds are widely researched in a lot of industry. From my reading, CLITORIA TERNATEA is one of the plants that hold such unlimited opportunity. Significance of study. CLITORIA TERNATEA is normally used as traditional medicine to treat illness and diseases. This study identifies the chemical composition from the roots extract of CLITORIA TERNATEA and its antibacterial activity. This study will contribute in identifying the chemical compounds responsible for the antibacterial properties, and the study on the antibacterial activities of roots of CLITORIA TERNATEA will contribute on developing this species as a potential value-added product in pharmaceutical industry. The objective of this study are to determine the phytochemical constituents of CLITORIA TERNATEA roots. The extract using tests for alkali, tannins, glycoside, steroid, saponin, flavonoid, and also test for phenolic. And also, the second objective is to evaluate the antibacterial activities of CLITORIA TERNATEA L root extract by using this diffusion method. For the literature review, I will cover biology and bioactive compounds, chemical constituents, and antibacterial activities of CLITORIA TERNATEA roots extract. The roots consist of a thick horizontal root with few branches and many slender lateral roots, and shows 10 to 20 or more layers of rectangular, thin-walled, tangentially elongated, exfoliating cord cells. Roots of CLITORIA TERNATEA is suitable to use as tonic because the roots are bitter, ophthalmic, laxative, diuretic, and depurative. From the scientific studies, CLITORIA TERNATEA roots extract can increase red brain acetyle, which in a similar fashion to the standard several drug. Thus, it shows that the root is considered as a good brain tonic, and it can be used for throat and eye infections, skin diseases, and ulcer. The long history of uses of CLITORIA TERNATEA indicates that this plant is safe to be consumed. A study shows that CLITORIA TERNATEA roots possesses several biological activities such as anti-inflammatory, analgesic, antipyretic, anthelmintic, antimicrobial activity, and also antibacterial activity. Phytochemical screening of the roots of CLITORIA TERNATEA shows the presence of ternatins, alkaloids, flavonoids, saponins, tannins, carbohydrates, proteins, resins, starch, terazoran, and terazoran. The chemical compound found in CLITORIA TERNATEA of roots are shown in Table 1, where it shows the quercetin and tannic acid are in charge of the antioxidant activity, while terazoran as well as terazoran are responsible for the anti-inflammatory activity, while for antibacterial activity, saponin and flavonoid glycoside are in charge for it. Antibacterial, or also can be referred as antibiotic, is a type of antimicrobial substance active against bacteria. Therefore, many researchers focus on finding natural plant extract that possesses antibacterial activity. From the root extract of CLITORIA TERNATEA L, flavonoids and phenolics have shown immediate antibacterial activity via interactions with proteins on the bacterial cell wall. So, it shows the antibacterial activity of CLITORIA TERNATEA root extract was potent due to the presence of flavonoid in the plant. In addition, another study shows that CLITORIA TERNATEA roots provoke the antibacterial action against Bacillus and E. coli. This study are made by Rajit and Kumar. Both of the tests performed by using this diffusion method. From this, it shows that CLITORIA TERNATEA roots possesses antibacterial activity. These are our methodology of this study. The first step is collecting of CLITORIA TERNATEA roots extract and then proceed with chocolate extraction process. The crude oil that got from the extraction has been used for the antibacterial activity and phytochemical screening test. For the chocolate extraction process will be as follows. These are the phytochemical screening tests that have been done by various methods. There are tests for alkali, glycoside, tannin, steroids, saponin, flavonoid, and phenolics. The first method for antibacterial preparation and test is preparation of malolactic alga. Next is preparation of nutrient broth. The third step is preparation of inoculum. And lastly is spreading bacteria and agar diffusion method. Moving on to the discussion. For the discussion, I will discuss the percentage yield of crude oil, phytochemical screening, and also antibacterial activities of CLITORIA ternatea root extract. The percentage obtained was used to compare the quantity of plant extract with actual quantity of plant sample. Table 2 shows the result of percentage yield from roots. The percentage yield from 12.0331 gram roots powdered in 90% ethanol is 3.44%. 7 classes of compounds have been tested, which are alkali, tannin, glycoside, steroid, saponin, flavonoid, and phenols. Table 4 summarizes the phytochemical screening result. Positive sign indicate the compound is present, while the negative sign shows the compound is absent. Based on Table 4, root extract was tested negative for alkalis, tannins, and glycosides, while the root extract shows positive result for the steroids, saponins, flavonoids, and phenols. The results are compared with the study that used the same method but with different concentration of solvent. It shows the study reported the presence of steroid, saponin, flavonoids, and glycosides in the root extract. The difference in compounds detected might be influenced by the few factors such as salinity of soil, geographical location, and concentration of solvent used. Figure 6, 7, 8, and 9 shows the presence of steroid, saponin, flavonoids, and phenols. The inhibition zone of each concentration against gram-negative bacteria E. coli and gram-positive bacteria B. laciniformis was compared with the standard inhibition zone of positive control, which gentamicin, to know whether the sample is effective or vice versa. If zone inhibition of concentration is more than zone inhibition of positive control, it is effective, while if zone inhibition of concentration less than zone inhibition of positive control, it is less effective. And lastly, if zone inhibition of concentration is less and equal to zone inhibition of negative control, which is DMSO, it will consider not effective. Table 4 shows the mean zone inhibition of the positive control gentamicin, negative control DMSO, and 3 concentration of root extract. The result shows the highest concentration of root extract. 30 ppm have the highest inhibition zone, which is 13.3 plus minus with 1.2 mm and 12.7 plus minus with 2.5 mm against gram-positive bacteria B. laciniformis and gram-negative bacteria E. coli respectively. While the lowest concentration of root extract, which is 10 ppm, give the lowest inhibition zones. Okay, so this indicates that the higher the concentration of root extract, the higher the zone inhibition. But when comparing all the concentration with the demeter of inhibition zone of gentamicin, it shows all the concentration is less effective against the bacteria. This is because a few replicates were contaminated and the discs were not in a good contact with the agar. This might interrupt some of the result. Results for each replicate against gram-positive bacteria and gram-negative bacteria are shown in Figure 10 and 11. From Figure 10A and 11C shows the misplacement of the disc of the first replicate against gram-positive bacteria and the third replicate against gram-negative bacteria, where this might cause why the disc is not in good contact with the agar. We must ensure each disc contact with agar by lightly touch with forceps, and the disc cannot be moved or their zone size may be affected. Next, Figure 11B, which the second replicate against gram-negative bacteria appear was contaminated. This is due to the fact that after being removed from the refrigerator and placed at a room temperature, the agar had some water on it, which may have resulted from the condensation process. As conclusion, the mass and the percentage of crude oil of CLITORIA ternatea root extract is 0.41385 gram and 3.44% respectively. For phytochemical screening study, CLITORIA ternatea root extract shows the presence of steroid, saponins, flavonoids, and phenols, while alkaloids, tannins, and glycosides were absent. In antibacterial test, the result shows the TPPM has the highest inhibition zones. The inhibition zone was compared with positive control, gentamicin. It shows the root extract has low effectiveness against gram-positive bacteria and gram-negative bacteria, because the inhibitory zones are lower than positive control. As the conclusion, the concentration of the root extract, which is the 30 ppm and the lower, CLITORIA ternatea in this experiment are not recommended to use as antibacterial agent as it has low effectiveness. For the recommendation, the development of new method for extraction techniques such as supercritical fluid extraction is recommended because this method is more effectively to extract the useful major compound in the extract, and it also more easy and faster. In addition, additional studies are required by testing with other type of bacteria, which includes gram-positive bacteria and gram-negative bacteria, in order to explore the behavioral activity of CLITORIA ternatea root extract against them. Last but not least, it is recommended to increase the concentration of root extract to get higher diameter of inhibitory zone, which then will be susceptible, which is effective against bacteria.